Hello student, it is a trial run. Already you have done the PN junction diode. Here I will discuss today about the function of this PN junction, the highlights only. Suppose, let me first discuss about the P-type and N-type crystal. Though we know, I am giving some ideas. Suppose this is one silicon crystal, pure silicon crystal. See, all the four outer shell electron of silicon, they make the covalent with the other silicon atoms. So see, I am showing only the middle one, silicon, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in this way, others all are there making this type fashions. Now, if I want to convert it into the extrinsic semiconductor, like suppose P-type, then what we will do? Generally, it is observed that we use the boron, the tetravalent atom type, valence is 3, outer shell electron is 3. This type atom if we add, then the 4 electron of silicon is there, but boron has 3 electrons, so we get one free space. That means there will be one vacant space, we call this is the holes. And in this way, in the total silicon, 1001 lakhs silicon atoms are there, and we use some small amount of boron, so they will create so many holes there. So this picture what we draw, remember here inside the background there is a silicon crystal. We don't make it clumsy, so we don't draw the silicon atom, we show only the holes, These are the free carriers, okay. So as they are free electrons, so they are in the conduction band, because these electrons, those who are attached in the valence shell, they are in the valence band. But these free electrons or free holes here, they are in the conduction band, okay. This is a separate one. Now in case of N-type, what we do, we put the arsenic here. Whenever we put the arsenic, then arsenic have the 5 electrons in the outer shell. So 4 electron will make the covalent bonding, 1 electron will be extra. So what these extra electron will go? These extra electron, we draw the picture like this. These are the extra electrons. But there is the silicon crystal lattice is everywhere. On there are small electrons that we project here only. So this is the majority carrier of N-type, this is the majority carrier of P-type. And when we meet these two, that means P-type and N-type, two crystals are placed side by side. That means one total silicon foil is there. You put boron one side and arsenic one side. So what will happen? This side will be P-type, this side will be N-type. In this way we can make a PN junction diode. So when the PN junction diode is made, then what will happen? It converts into a PN junction diode. अभी देखना है डायोड का मतलब क्या है. देखो अभी जो गुड कंडक्टर है, if it is a good conductor, then you can pass the current along this direction. At the same time you can pass the current in opposite direction also. This is possible for the good conductor. अभी जो इंसुलेटर हो गया, इंसुलेटर में क्या होगा? If you want to pass the current, they will not go. If you want to pass the current in opposite direction, then also it will oppose the current. You cannot pass the current through it. But in good conductor, you can pass the current in both the direction. But the semiconductor diode, PN junction diode, इसका मजा ये है, ये भी semiconductor diode हो गया, तो इसमें current इस side में जा सकता है. Suppose current is going along this direction, but remember, if the current wants to come back to in opposite direction, they will not come. Just like चक्रव्यूह जैसा है, ऐसा एक तरह से जाने का रास्ता तो उसको मिल गया, लेकिन बाहर आने का कोई रास्ता नहीं है. That means the current can flow in only one direction. So this is the magical technique of the semiconductor diode rather than the good conductor or the insulator. Good conductor में दोनों साइड में जा सकता है, इंसुलेटर में कोई भी साइड में अलाउ नहीं करेंगे, लेकिन सेमीकंडक्टर डायोड में it will pass the current only in one direction. अभी देखना ये पीएन जंक्शन का अंदर में क्या मैकेनिज्म है, जिसलिए ये जिस प्रॉपर्टी शो करता है कि करंट एक साइड में जाता है, दूसरा साइड में ये ब्लॉक कर देता है. कैसे होता है देखो. सपोज एक पीएन जंक्शन डायोड का पिक्चर बना लेते हैं. सपोज P-type और N-type क्रिस्टल जैसे होता है, ऐसे एक ब्लॉक में सपोज दिस साइड में हम P-type ले लिया, दिस साइड में हम N-type ले लिया, P and N. So and they will join. Suppose this is the middle section, this is the P-type and N-type. If it is P-type, we know that the majority carrier according to these holes are the majority carrier, okay. And in N-type, we know that electrons are the minority carrier, majority carrier, sorry. And remember, minority carriers are also there. I am not showing just now. Now, if they come in this way, then now what will happen? P-type holes will see there is a negative side, and negative side will see there is a positive side. So automatically they will try to diffuse, just like gas diffusion. In case of gas, when the two gases are separated and if we omit the barrier between them, total gas will mix up. But in this case, total electron and holes will not mix up, but there will be diffusion. How they will diffuse? Suppose some electron, this electron from inside, it comes to this direction. So there is a holes. If we combine with the holes, So automatically they will cancel each other. So that means whenever they will cancel, there will be no charges in between these two parts. In this way, so many electrons will cross the barrier in normal position due to diffusion. So when the negative charges are going on, automatically one positive potential will be developed in this region, along this region. One positive potential will be developed. At the same way, as the electrons are coming to this side, here the negative potential will be developed. So in this region, we can say one EMF will be developed into the diffusion of electron and holes. We can think in this way also. Electrons are coming to this side, so there will be negative potential, and as the holes are diffusing along this direction, so there will be a positive side in this region only. After that, you can say that they will continue, but they will not continue. Why? Because once the holes are coming to this position, so when next hole will try to go, this will repel it. Same way, when the electrons are here, so automatically what will happen? These electron when wants to come, they will repel it. So this diffusion will stop after some times. So this is the basic difference with the gas diffusion. In case of gas, all the molecule will diffuse, but here it will stop due to this barrier. Now इसमें क्या होगा? अब ये हो गया जो ये जो बीच वाला का रीजन है, इसमें एक पोटेंशियल डेवलप कर गया. इस साइड में पॉजिटिव, इस साइड में नेगेटिव पोटेंशियल डिराइव. So let me draw a bit so that I get the space. So a region हो गया. This region is called the depletion region. So this region is called the depletion region. And इसमें पॉजिटिव पोटेंशियल, इस साइड में नेगेटिव पोटेंशियल डेवलप हो गया. तो ये जो पोटेंशियल बैरियर क्रिएट हो गया, ये पोटेंशियल का एक नाम है, इसको हम कहते हैं बैरियर पोटेंशियल. So this is called the barrier potential. And barrier potential, actually it is observed that in case of silicon it is nearly equal to 0.7 volt, and if you consider the germanium, then it is nearly equal to most probably 0.3 volt like this. So let me consider the silicon crystal. So in silicon crystal, the barrier potential of 0.7 volt has been developed in the depletion region. So this is the basic condition that due to diffusion, some electron will come to the p side, creating a negative potential, and some holes will go to the another direction due to diffusion, creating a positive potential. It creates barrier potential. In case of silicon type crystal, it comes nearly 0.7 volt in initial position. So automatically, if I consider the electric field direction, we know that electric field comes from positive to negative side. So according to this, in this picture, from positive to negative side, we can get one electric field like this. So this is the position before connection. Okay. अभी क्या होगा? Now I will connect the battery. The battery connection दो तरीके से होता है. Let me first consider. Let me drop this one. Depletion region. Remember the name. एक जो होता है, we can connect in this way. P type is connected with the positive terminal of the battery, and N type is connected with the negative terminal of the battery. Don't connect first. Keep on switch, it is open. So this is the picture initially. So ये जो कनेक्शन है, इसमें P टाइप का सब पॉजिटिव है, इन साइड का सब नेगेटिव लगा हुआ है. इसको हम कहते हैं फॉरवर्ड बायस कनेक्शन. सो दिस इज कॉल्ड द फॉरवर्ड बायस कनेक्शन. इसका उल्टा भी हो सकता है. दैट आई विल शो इन नेक्स्ट पिक्चर. दैट P टाइप का सब नेगेटिव लगा दिया, इन टाइप का सब पॉजिटिव लगा दिया. उसमें दूसरा फंक्शन होगा. पहले देख लीजिए ये फॉरवर्ड बायस में क्या होता है. फॉरवर्ड बायस में व्हेन इट इज कनेक्टेड विद द P विद द पॉजिटिव एंड A विद द नेगेटिव, अभी क्या होगा, ये पॉजिटिव जो पोल है, पॉजिटिव पोल क्या करेंगे, इसको ये पॉजिटिव जो होल्स है इसको पुश करेंगे जाने के लिए. सेम वे दिस नेगेटिव पोल क्या करेंगे, नेगेटिव पोल विल पुश द इलेक्ट्रॉन टू मूव इन द फॉरवर्ड डायरेक्शन. दैट मीन्स नाउ द मेजॉरिटी कैरियर ऑफ P टाइप होल्स and majority carrier of N type electrons, they will be pushed together to move towards the depletion region. So they will try to hit the depletion region. Generally, for simply understanding, we can say they will break the depletion layer. But matter is not so. Suppose it is a variable battery, you can change the voltage gradually. So if we change the voltage, we can supply more and more voltage. Let us consider that initially when we start, the voltage is less than this 0.7 volt. Suppose it is 0.1 volt, then we will increase 0.2 volt. In this way, gradually we increase the battery voltage. So when the voltage is lower than the barrier potential, then it has no effect. Why? Because you see, this is positive terminal, this is negative terminal. So what will be the direction of electric field? From this direction to this direction. So this battery will try to make one electric field along this direction from positive to negative, and barrier potential will create one electric field in opposite direction. So there will be a collision between the two electric fields. But when it is 0.1 volt, these electric field cannot do any work because this is a strong one. So let me draw one graph, it will be easier to understand. Suppose Ohm's law type characteristic curve, voltage is there and current is there. Now you increase the voltage 0.1 volt. When 0.1 volt will increase, they will be pushed always, but they cannot cross the barrier because the electric field is strong from this direction. This direction will not work at all. So we don't get any current. We don't get any current. 0.1 volt, 0.2 volt, 0.3 volt. In this way, suppose here it is 0.7 volt. Suppose gradually we are increasing. So when it is 0.1 volt, 0.2 volt, this battery voltage, they cannot cross this barrier as the electric field of barrier potential is higher than the battery potential. We don't get any current. See, we are not getting the current. In this way, अभी क्या होगा जब बैटरी पोटेंशियल चेंज करते करते इसको हम सपोज 0. इस पिक्चर में सिलिकॉन क्रिस्टल के लिए 0.7 वोल्ट बना दिया तो क्या होगा अभी when this battery voltage becomes 0.7 volt, now it equals to the barrier potential. So what will happen, this electric field and this electric field, they will cancel each other as these two are equal. So क्या होगा अभी ये जो बैरियर जो हुआ था डिप्लेशन लेयर ये वैनिश हो जाएगा. डिप्लेशन लेयर का कोई ये अस्तित्व भी नहीं रहेगा, ये पूरा चला जाएगा क्योंकि अभी इन दिस पोजीशन 0.7 volt of the battery and 0.7 volt of the barrier potential, these two are equal, they will cancel each other, so depletion layer will vanish. So when the depletion layer will vanish, now electron can easily pass from this direction to this direction. At the same way holes can move along this direction. Now the passage is clear. That means we get a huge current. So this at 0.7 volt, though the current is coming like this, now it will increase gradually and it will move very fast because now there is no obstruction. It will increase gradually. So current will increase gradually. So in this position, this 0.7 volt, it is very important one in this particular case, that whenever we make the voltage 0.7 volt, then it equals to the barrier potential and barrier vanishes. When the barrier will vanish, then the electron and holes, they can easily pass. That means we can get the conduction, we can get the current, we can get a huge current. And remember one point, this 0.7 volt, it has one name in electronics. This we call the knee voltage. We call that this is the knee voltage, where this breakup going on and the electron get a passage like this. तो ये तो हो गया अभी फॉरवर्ड बायस के लिए. तो देखना है अभी रिवर्स बायस में क्या होता है. रिवर्स बायस में लिए पहले वाला पिक्चर जल्दी में बना लेते हैं. जो था कैसा था उसमें बैरियर पोटेंशियल ऐसा था, पॉजिटिव इस साइड में हुआ, होल्स डिफ्यूजन के लिए पॉजिटिव बैरियर हो गया और इलेक्ट्रॉन बिना जाने के लिए इलेक्ट्रॉन का लेयर बन गया. ऐसा था पहले. अभी इसको बैटरी कनेक्शन हम रिवर्स कर देते हैं. रिवर्स करने का मतलब क्या है, अभी P विथ नेगेटिव एंड N विथ पॉजिटिव, जस्ट रिवर्स. P विथ नेगेटिव एंड N विथ पॉजिटिव. अभी जो कनेक्शन होगा इसमें क्या होगा, सपोज इनिशियली नाउ 0.7 volt when the switch is open and our battery is also a variable battery voltage. So what will happen, if we increase the voltage gradually, then what else, just make it on, increase the voltage equally. Now see, here the question is that now when it will be 0.7 volt, 0.7 volt, now the barrier will not vanish. Why? Because this negative potential, what they will do, they will pull the positive charges along this direction and this positive charge will pull the electron to come along this direction. That means they will go along two directions. So automatically this barrier will increase in volume. So we can say that depletion layer will increase in size. Depletion layer will increase in size. क्योंकि अभी इलेक्ट्रॉन जो है ये पॉजिटिव पोलैरिटी इलेक्ट्रॉन को इस साइड में पुश कर लिया और नेगेटिव पोल जो है वो होल्स को इस साइड में ले लिया है. तो क्या होगा, अभी जो बैरियर था पोटेंशियल डिप्लेशन लेयर का, जो पहले इतना से इतना दूर तक था, अभी ये इतना बड़ा हो गया. डिप्लेशन लेयर बड़ा हो गया. ठीक है, डिप्लेशन लेयर बड़ा हो गया. डिप्लेशन लेयर बड़ा होने का मतलब क्या है, ये बैरियर पोटेंशियल भी चेंज हो गया. तो बैरियर पोटेंशियल जो पहले 0.7 वोल्ट तक ज्यादा हो गया क्योंकि इससे बड़ा हो गया. इलेक्ट्रिक फील्ड भी पहले से बड़ा हो गया है. तो इन दिस वे you see that instead of breaking up this depletion layer, because this battery have a tendency positive to negative, that means इसका जो मतलब है ये इलेक्ट्रिक फील्ड इस साइड से इस साइड में ट्राई करेगी. और डिप्लेशन लेयर का था ये भी था. जस्ट रिमेंबर इन केस ऑफ फॉरवर्ड बायस इट वाज लाइक दिस. फॉरवर्ड बायस डिप्लेशन लेयर, there is positive negative. The depletion layer have a electric field along this direction and we connect the battery in this way. There was positive and there was negative. Okay, so positive to negative will create the electric field along this direction. So they were in opposite direction, they will try to cancel each other. But in this case, depletion layer positive is here, depletion layer negative is here. They will create a electric field along this direction. And what the battery will do, battery is also now positive to negative along this direction. So this electric field is also in same direction. So automatically electric field also increases. So due to this one, depletion layer is increasing, we don't get any current at all. So if we increase the voltage gradually, we don't get the current. So in graph you can show this is the negative voltage. If you increase the voltage, we don't get current, but we get a very light small amount of current. You can neglect. We don't get current any at all. But there is a very small current. This is due to the minority carrier. I'll show. Now इसका बात एक काम होगा अभी. Suppose battery voltage increases to some high extent. Suppose we are increasing it to 70 volt to 80 volt like this. Then what will happen? If we increase the 70 to 80 volt, then अभी क्या होगा? इसमें जो minority carrier कौन था? Electron और N type में minority carrier कौन था? Let me remove this E. These are making clumsy. So there are holes. Now this is minority carrier and here the minority carrier is the electron. See, अभी जो बैटरी का वोल्टेज स्ट्रॉन्ग हो गया, तभी क्या होगा, ये जो पॉजिटिव पोल है ये इलेक्ट्रॉन को पुल करेंगे इस साइड में, और ये जो नेगेटिव पोल ऑफ बैटरी है दे विल अट्रैक्ट द होल्स ऑफ दिस माइनॉरिटी कैरियर. सो इन दिस सिचुएशन माइनॉरिटी कैरियर दे आर गेटिंग द स्कोप टू मूव अलोंग ऑपोजिट डायरेक्शन बिकॉज नेगेटिव विल पुश दिस इलेक्ट्रॉन एंड दिस पॉजिटिव विल मूव दिस होल्स. दे आर द माइनॉरिटी कैरियर. सो क्या होगा, अभी माइनॉरिटी कैरियर के लिए अभी जो वोल्टेज ऐसा ज्यादा हो गया, उसके बाद क्या होगा, ये इलेक्ट्रॉन अभी क्रॉस करने का रास्ता मिल गया इसको, ये क्रॉस करना चाहेंगे. क्रॉस करते करते इसको इस साइड में चला आया. यहाँ आने के बाद क्या होगा, यहाँ आने के बाद से ये पॉजिटिव पोटेंशियल है तो ये तो मूव करेंगे विद हाई काइनेटिक एनर्जी. जाने का टाइम क्या है, इसमें तो ये है सिलिकॉन क्रिस्टल है. तो सिलिकॉन का जो 4 इलेक्ट्रॉन आउटर वैलेंस इलेक्ट्रॉन है, ये वाला जो इलेक्ट्रॉन है, सपोज यहाँ देखा था सिलिकॉन को, अभी सपोज सिलिकॉन क्रिस्टल का जो 4 इलेक्ट्रॉन इधर है ऐसा करके बंद बना हुआ है. अभी these electron with a high kinetic energy will hit the silicon crystal of this depletion layer region, and when this will hit the electron of the silicon outer shell valence electron, this valence electron भी निकल जाएगा, तो ये भी फ्री इलेक्ट्रॉन हो जाएगा. तो क्या होगा, अभी ये तो इलेक्ट्रॉन था ही, एक इलेक्ट्रॉन था, वो हिट करके दूसरा इलेक्ट्रॉन भी निकल दिया. ऐसा करके जितना भी इलेक्ट्रॉन आएगा, जो माइनॉरिटी कैरियर है इस साइड का, माइनॉरिटी कैरियर विद हाई काइनेटिक एनर्जी विल हिट द सिलिकॉन क्रिस्टल ऑफ दिस रीजन एंड इन दिस रीजन ऑफ द डिप्लेशन लेयर, एंड फ्रॉम दिस सिलिकॉन क्रिस्टल वैलेंस बैंड दे विल रिलीज द इलेक्ट्रॉन्स. सो व्हाट विल हैपन, द इलेक्ट्रॉन concentration will be more. I am repeating once. This is the minority carrier electron. When it gets the high voltage, then this negative will push and it will get a high kinetic energy. With this high kinetic energy, when it will enter and cross the boundary, then in this depletion layer only, there are the silicon atoms, silicon valence electrons are there, they will hit the valence electron and they will release the valence electron. That means the electrons becomes now the free electron. So ये तो एक इलेक्ट्रॉन था ही, वो दूसरा को एक सिलिकॉन से दूसरा इलेक्ट्रॉन को भी निकाल दिया, तो एक इलेक्ट्रॉन से 2 इलेक्ट्रॉन हो गया. ऐसे 2 इलेक्ट्रॉन से 4 इलेक्ट्रॉन होगा, 4 इलेक्ट्रॉन से 8 इलेक्ट्रॉन हो जाएगा. ऐसा करके बहुत इलेक्ट्रॉन एक साथ आने के लिए हम क्या होगा, इलेक्ट्रॉन क्रॉस करके इस साइड में चला आएगा. वी कैन गेट ए करंट बट दैट विल बी वेरी ह्यूज अमाउंट ऑफ करंट बिकॉज दिस इलेक्ट्रॉन ऑलरेडी ब्रिंग्स आउट सो मेनी free electron from the crystal lattice. So all these electrons when comes out, we get a huge amount of current and it shows like this. At a very particular high voltage, we get a high amount of current. Why? Because due to this collision. So this voltage has some name. We call this is the breakdown voltage. We call this is the breakdown voltage of reverse bias. In this position, what happens actually, the depletion layer remains big, no problem. But this minority carrier, they moves and they will hit the crystal lattice of silicon, brings out so many free electrons. We can get a huge amount of current. We call that breakdown voltage. This is called the breakdown voltage in reverse bias. Okay. Generally, we don't get the current due to this barrier for the majority carrier. But minority carrier, when it moves at this particular voltage, very high voltage, they will hit the silicon crystal, brings out the free electrons, from valence electron to free electrons, and huge free electrons will come out. We get a high value of current, that is called the breakdown voltage. So this voltage is called the breakdown voltage. But remember one thing, as the electrons are making collision with the crystal, So it will develop the heat. It will develop the heat as it is making the collision with the silicon atom continuously. Due to this heat, these crystal or PN junction diode, they can destroy. So in negative this breakdown voltage position, if I apply this amount of voltage, हम तो करंट तो मिलता ही है, ठीक है, ज्यादा करंट मिल गया, लेकिन इसका नेगेटिव साइड क्या है, इतना भी हीट डेवलप होगा जो पूरा क्रिस्टल जो है पीएन जंक्शन डायोड ये खराब हो जाएगा. सो इन नॉर्मल पीएन जंक्शन डायोड we don't try to go to the breakdown voltage. Once we reach to the breakdown voltage, we can get a huge amount of current, but the PN junction diode will destroy. So these will be destroyed due to the production of the heat due to this collision. As the electrons minority carrier hits the silicon crystal, due to this heating effect, it produces the amount of heat, and this heat will destroy the total crystal. We get this one. So these characteristics is called the PN junction forward bias, PN junction reverse bias. Forward bias, we don't get the current initially. At the knee voltage, that means when the battery voltage equals to the barrier potential voltage, then we get a huge amount of current, because तब जो होता है, जो barrier जो है depletion layer, वहाँ से just it becomes clear. So you get a passage, you get a huge amount of current. और yes, reverse bias में क्या होता है? Reverse bias में due to this polarity, opposite polarity, no your majority carrier will flow and the depletion layer will increase in size. So we don't get current at all actually. But one point is there, when the battery voltage is very high, दिस क्रिस्टल के लिए सपोज सिलिकॉन क्रिस्टल 70 to 80 वोल्ट चाहिए अभी, सो इसको वोल्टेज देने से क्या होता है, माइनॉरिटी कैरियर अभी एक्शन स्टार्ट करता है. माइनॉरिटी कैरियर हाई काइनेटिक एनर्जी लेके एक बाउंड्री क्रॉस करना चाहते हैं, और जो सिलिकॉन एटम है, सिलिकॉन एटम के हीट करने से उसमें से इलेक्ट्रॉन चला आते हैं. इलेक्ट्रॉन चलाने के बाद क्या है, इलेक्ट्रॉन को इसको निकाल देते हैं. ज्यादा से ज्यादा इलेक्ट्रॉन निकालने से हम ज्यादा करंट मिलता है, ठीक है, लेकिन जो होता है उसमें क्या होता है, जो सीधे इलेक्ट्रॉन निकालने से बाद ये पूरा डिस्ट्रॉय हो जाता है ड्यू टू द हीटिंग इफेक्ट. सो दिस अबाउट द फॉरवर्ड कैरेक्टरिस्टिक्स एंड रिवर्स कैरेक्टरिस्टिक्स ऑफ पीएन जंक्शन. ओके, सो दिस इज अ ट्रायल रन. लेट्स सी. ओके.